get comfortable with it. All right, let's just work with this. Parents have 10 books that they can read to their children this week. 5 of the books are nonfiction and 5 are fiction. If the order in which they read the books is not important, order is not important, that tells me right there it's a combination. How many different sets of 4 books can they choose? Doesn't matter what order. So that means I have 10 books and I need to choose 4. I want to find out how many ways I can do that. If I plug it into here, that means this is my n, this is my r. I have 10 factorial over n minus r, which is 6 factorial, times r factorial. And if you wanted to just do that on the calculator, you could. You can also just do this on the calculator. Same place as permutations was on the math and probability. You all saw that, right? If you watched the video, you saw it. And this equals 210 ways. Now let me show you actually numerically why that works that way. And you can write it down or not. You can just watch. 10 factorial is obviously this. 6 factorial. And then I have 4 factorial. What happens to these numbers? These all just cross out, don't they? Also, the 6 and the 5. So I actually just have those top numbers divided by the bottom numbers. And that's where 210 comes from. Okay? All right. In how many groups? Oh, there's that key word. Groups. Yes, Rosie.
Will we have calculators on this?
You will, but you might need to write this out.
All right.
But you can still check your answer with the calculator if you need to. Okay. In how many groups? Excuse me, let me back up. I say that now. Last year you could use a calculator. Hopefully we'll still be able to. In how many groups? I know. Of 4 books, are all the books either nonfiction or fiction? Let me just explain something that I did not have you write up here. I want you to write up here. If you have and events, you're going to multiply. And this will come into play shortly. If you have or events, you're going to add. The combinations. So here it says, in how many groups of 4 books are all the books fiction or nonfiction? That means they want to pick 4 books and they want them all to be fiction. Or all nonfiction. It's an or, which means you have to add the 2 different ways. So I'm going to start with fiction. How many total fiction books do I have? Now I want to know how many ways I can take 5 and choose 4 of those fiction. Then I got to add to it the ways I can do nonfiction. Again, I have 5 nonfiction, and I want to know how many ways I can choose 4. So for both of these to happen, you add them together and find out how many ways possible that is. And when you do the math, this is actually 5, and that's actually 5. 5 plus 5 equals 10. If you were to plug this into this, you would get 5. If you were to plug this into your calculator, you would find out it's 5. Okay? I didn't just make that up. All right, turn the page. Oh, they're out of order, by the way. Well, this is the 3rd page, so your thing is probably out of order. They were stapled wrong. This is the 2nd page here. Okay, the Student Senate consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. When I see a list like that, I think, maybe I need the total. I'm just going to write it down just in case. 18 total. Maybe. We'll see. Especially since we're working with probability. How many different committees, there's that word again, it's a combination. Order doesn't really matter. Of exactly 2 seniors and 2 juniors can be chosen. If it's an and, I have to multiply. It's not 2 separate instances. Okay? So I got to multiply. All right, how many seniors do I have altogether? So I want to find out how many ways out of 6 seniors I can choose 2 of them. How many juniors do I have altogether?
5.
So how many ways can I take 5 juniors and choose 2 of them? And I'm going to multiply these 2 numbers together. It's not separate. When I do that, if I do 6 choose 2, I get, I think it's 15. Remember, I think it's 15. Anybody know that? Yeah. And then this is 10. This is 15, this is 10. Equals 150. So there's 150 ways to choose 2 seniors and 2 juniors for my committee. Okay? Okay, how many different committees? Yes, Ryan?
Wait, how'd you get the 15 again?
If you think about, I just kind of know this in my head. You don't have to know it in your head, but if you plugged 6 choose 2 in here, you would get 15. Or if you did 6 choose 2 on your calculator, it would be 15. That's what 6 choose, because it's 6 times 5 over this thing right here, and it will give you, yeah, it's 30, ends up to be 30 over 2. How many, I don't have a lot of time, so I'm going to keep going. How many different committees, again, it's a combination of at most 4 students can be chosen. Wait a minute. Does that mean I can have more than 4 or less than 4? So I want to know 4 or less. Oh, there's that or word. 4 or less. So this is where I need my total, because they're not specifying by class here. So out of 18 kids, how many ways can I choose 4 students? That would be 1 committee with 4. Or out of 18 students, how many ways can I choose 3 students? That's a committee of 3, which is okay. You see where I'm going with this? Or a committee of 1, that'd be pretty boring. When you do all of these together, you get 4,047. That's a lot of ways to be able to choose all those committees out of 18 people.
That's wild. Do people really spend time figuring this out?
People do.
They need to get a life.
You are going to toss 10 different coins. How many different ways will at least 4 of the coins show heads? So that means I want 4 or more. How many ways will 4 or more of the coins show heads? There's that or again. So I have 10 coins total, and I want to know, let's say, how many ways 4 of them will show heads. Then I got to go up. 10 coins total, how many ways could 5 of them show heads? And we got to go all the way up to 10. So this is this requirement, 4 or more. How many ways 4 or more of the coins are going to show heads? And when you do that, you'd think it'd be a huge number, but it's really not. It's only 848. Because really, there's not very many ways that this could happen, is there? There's one way that can happen. So it's not that many. There's only 10 ways that can happen. All right, that's part 1. Part 2, how many people have seen Pascal's triangle before? It's shown below with its entries represented by combinations. Ladies and gentlemen, Pascal's triangle has all sorts of magical things that occur within it. However, we're going to use it for one thing in this section, which is really kind of cool. There is an infinite number of rows in Pascal's triangle. It goes forever. Notice that it starts with 1, and all the way down the left side is 1, all the way down the right side is 1. And you can get each of these numbers inside here by adding the 2 above it. 1 and 2, 2 and 1. You see that? It's pretty nifty, isn't it? I will give you Pascal's triangle, but if you had to create it on your own, it's pretty easy. This is Pascal's triangle represented as combinations. So here, this is row 0. 0 choose 0 can only happen one way. 1 choose 0 can only happen one way. If I go down here, 3 choose 1, this is in the same spot as this 3. That can happen 3 ways. So this is kind of a cool way to show you the answer to those combinations. Like this one right here. 5, choose 1. That can happen 5 ways. It's in the same position.
Oh.
Okay? 5, choose 3 can happen 10 ways. Because this is represented as combinations here. That's how you say it. 5, choose 3.
Okay, I was like.
That's how you say that, C. Okay? All right, I need you to add on 2 rows because we're going to need them. So you always start with 1. Notice 1 is all along the outside. How do I get this next number? 1 and 5 is 6. 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And then 1. That's row 6. Look, you start with 1. This number comes from adding 1 and 2. The next number comes from adding 2 and 1. Okay? Then I want you to do this next row. Jump in and try it on your own. And then we need, because we need row 7. See, she's tired at the end of the day too. So you should have 1, 7, 21, 35, 35, 21, 7, and 1. And look what I gave you on the back. Yeah, it goes forever, but this is just part of it. Let's fill in the rows while we're here. This is 0. This is row 1, row 2, row 3, row 4, 5, 6, and 7. Okay, rows. It keeps going. All right, let's use this. From a collection of 7 baseball caps, you want to trade 3. So you want to know how many ways out of 7 you can choose 3. Use Pascal's triangle to find the number of combinations of 3 caps that can be traded. So if I were to write row 7 as combinations, it would be 7, choose 0. See, just like the first one here was 5, choose 0. Then it would be 7, choose 1. 7, choose 2. 7, choose 3. So what number does that correspond with? 35. So 7, choose 3 is equal to 35. And I just got that off of Pascal's triangle. Could you put it on the calculator? Absolutely. Could you do the little formula? Absolutely. But you need to know how to use this for what we're doing next.
Is that going to be a test?
I'm going to give you Pascal's. Well, I did last year. I probably will do it this year too. Okay. Okay. Now let's go back to the 3rd page here. This is where you're going to use this information. This is a beautiful thing.
It looks like a roller coaster, like some sort of like magic mouse, like
Okay. Binomial theorem. It's a process used to expand binomials. Let's say you had something like this. That would be pretty crappy to have to FOIL out, wouldn't it?
Oh.
That's no fun. There's this beautiful method you can use off Pascal's triangle that does it really quickly. This looks nasty. I'm going to show you a much easier way than reading that thing. I'm a step person. I follow directions. I can't help it. All right, here's the step-by-step. The exponent tells you which row of Pascal's triangle to use as coefficients. I'll do this all with you, so don't worry. Write the first term from left to right with decreasing exponents. Write the second term from right to left with decreasing exponents. Simplify each column and fill in the signs. We're going to do it together. It'll make more sense. So we have to expand this binomial. Step 1 says the exponent tells you which row of Pascal's triangle to use as coefficients. So you go to your Pascal's triangle, to row 5, and you're going to write these numbers down. 1, 5, 10, 10, 5, and 1. But you're going to write a space between them. 1, 5, 10, 10, 5, and 1. Okay, this is row 5. That's how I got that. Then I'm going to draw like little columns. Don't make your lines too long, though. Just to help keep me organized. Not too long. Step 2 says write the first term from left to right with decreasing exponents. Here's my first term, x. I'm going to start with x to the 5th, because that's 5. Then I'm going to write x to the 4th, x to the 3rd, x squared. X to the 1, you can write the 1 or not, but stop. What is x to the 0? Anything to the 0 power 0 is 1. So it's really irrelevant, so you don't need to fill anything in there. Okay? Step 3 says write the second term from right to left with decreasing exponents. My second term is y. Y to the 5th from right to left. And then nothing here, because y to the 0 is 1. Then you draw a line. And you are almost done expanding that binomial. Now you're going to simplify each column. This is multiplication. What's 1 times x to the 5th? X to the 5th. 5 times this. You just write it down. It's 5x to the 4th y. That's that second term. Then you do this one. 10x cubed y squared. 10x squared y cubed. 5xy to the 4th, ending with y to the 5th. And then the very last step says fill in the signs. If it's a plus, then it's all plus. Boom, 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 and you are done. It's like way easier than expanding that binomial by hand. Here's what I want you to notice when you have two variables. Take a look here. Shh. Take a look. What's this exponent? It's 5. It's the same as that one, isn't it? Here's 4. Here's 1. They add up to 5. You see that? 3 and 2 add up to 5. 2 and 3 add up to 5. 4 and 1 add up to 5. Keep that in mind. Okay? Let's do another one. Okay, ladies and gentlemen, what row am I looking for this? This one's a little harder. What row am I looking at?
4.
Row 4. So I need 1, 4, 6, 4, and 1. Make your columns not too long. First step, this is trickier. My first term is 3x. So I have to do it to the 4th, but of course you have to put it in parentheses because the whole term is raised to the 4th, and that's going to make a difference later. And then 3x to the 3rd, 3x squared, 3x to the 1st. You can write the 1 or not. Here, you don't need to write anything. Then you do the second term, starting from the right, -2 in parentheses to the 4th. And nothing here, because it's just 1. This is where it's just a little bit trickier. Not bad. Yeah.
Why do you have numbers?
What?
Why do you have numbers under the, like, why do you have 3x and -2 instead of just x and y?
Because there's this first term here is 3x. And the second term is -2 in this binomial. Okay, let's look at this. Now, multiplication. I have to realize that 3x to the 4th means 3x times 3x times 3x times 3x. So I got to raise each of those to the 4th. What's 3 to the 4th? Does anybody know?
Oh.
It's not 12. The math gods will strike you with lightning if anybody says 12. It's 81, okay? So I have 81 times 1. 81 x to the 4th is my first term. 81 x to the 4th.
Yummy.
Okay, here.
9.
27.
3 to the 3rd is 27 times 4. I don't know what that is. Times -2. So 27 times 4 times -2 is minus 216 x cubed.
Okay, now it's 9.
No, it is. 3 squared is 9, yes. 9, now it's 9. 9 times 6 is 54 times 4 is what? Does anybody know? I think it's 216 again. Yeah, it is. It's 216. What's my x2? Squared. Pardon me?
Oh, never mind.
Okay, here. This is just to the 1, so it's just 4 times 3. What's negative 2 cubed? Negative 8. So negative 8 times 12 is minus 96x. No, negative 2 times negative 2 times negative 2. Be negative 8. And then this becomes a positive 16. Oh my word. What?
What's the exponent on the?
It's just x to the 1, or just x.
Wait, I don't get it. What determines the exponent of that?
Well, look, this is x squared, this is x cubed, x to the 4th.
Oh, okay.
Okay? Now, ladies and gentlemen, the last step is, if it's a minus, that should alternate minus plus minus, minus plus minus plus, keep going, we're good. Okay? Is that not just the funnest thing you've ever done? Okay. We got the grand finale here, you ready?
Basically,
Yeah.
Like the name Pascal.
Find, yes.
How come
All right, the last one here is, you're going to have a problem like this, and it's going to say, find the coefficient for that particular term in that expanded polynomial. You don't have to do the whole thing, okay? You just have to think about it a little bit. Obviously, you're going to be working with row 7, okay, in Pascal's. And if I want to get down to the 3rd position, it says, remember, I'll wait. When using the binomial theorem, x cubed would actually be the 5th spot in. So you need to know that number on Pascal's triangle, row 7. Let's think about this. If I were to write it out like this, I would have x to the 7th, x to the 6th, x to the 5th, x to the 4th, x cubed. That's the 5th spot in, wouldn't it be, on Pascal's triangle? So I go to Pascal's triangle, row 7, 1, 2, 3, 4, 5. 35 is going to be part of my coefficient.
Okay.
So write that down. 35 is part of my coefficient. All right, where am I here? 35. So this is from row 7, 5th spot. Okay, then you write what you need as multiplication. Okay, so I need where x is cubed, so that means I take the first term and I cube it. I need where x is cubed. Oh, wait a minute. What am I going to put on the y? Remember what I said up here? The two exponents have to add up to your original. So it's got to be negative y to the 4th, because 4 and 3 have to add up to my original. And then, instead of expanding that whole thing, you can just do the math with this, and you'll get the coefficient. 35 times 2 cubed is 8 times x cubed. You might want to think of this as a negative 1. So you might want to say, okay, negative 1 to the 4th and y to the 4th. What's negative 1 to the 4th? Negative 1 times negative 1 times negative 1 times negative 1. Which is positive 1, isn't it? So this is really irrelevant to the multiplication because it's positive 1. 35 times 8 is 280, x cubed, y 4th, so the coefficient is 280 at that spot. Isn't that crazy?